Hello everyone, in this video we will do some introductory calculus with parametric equations. So first let's recall what a parametric equation is, right? So this is where we have two functions, say x is f of t and y is g of t, right? And t is our parameter. And so we still graph on the xy plane, but we're viewing this as happening over time, right, where x and y are both dependent on this parameter time. So since we're still graphing in the xy plane, then when we talk about slope, right, dy dt, dx dt, these are things that make sense, right? These are the rates of change of y and x with respect to t, but they don't give us slope in the xy plane, right? For that, we still want to be thinking about dy dx. Right, so we still want this, but that doesn't seem as obvious, right? So if I'm given, for example, right, just x is, say, t squared plus 1 and y is t cubed minus 4t, right? Then it's easy to take each of their derivatives with respect to t, but I need some relation between that and the rate of change of y with respect to x, right? So how do I get this? Well, it turns out we can just use the chain rule. This is the key. So what do we know? Well, you can think of y implicitly as some function of x. In doing so, when you take the derivative of y with respect to t, right, if you view y as having this being implicitly a function of x, which is then a function of t, you can take the derivative of y with respect to the inside function x, and x being a function of t, we have to multiply by the derivative of the inside, x, with respect to time. And so this is what the chain rule tells us, right? And this is in Leibniz notation. Well, the guy I want here is dy dx. So I'm just going to go ahead and solve for it. Right, so dy dx is going to be dy dt over dx dt. Or if you want to use what we had on previously, right, this would be g prime of t over f prime of t. And of course, since we have a denominator here, we want the caveat, right, that this guy is not going to be 0 because we don't want to divide by 0. So our general rule here, right, is dy dx, which again, this is still slope of the tangent line, right? So if we're thinking in the xy plane, that's exactly what this still is, just like we learned in Calc 1. But we can write it in terms of how y and x are changing with respect to time in this way. So let's look at an example. Okay, so we're going to do a couple of things here. So we're going to use the functions we just saw. So let's let x be t squared plus 1, and let's let y be t cubed minus 4t. And first, we're going to start with just a tangent line at some point. So we'll just say a tangent line at t equals 3. Well, how do I find tangent lines? I want slope and I want a point, right? So one thing that's always easy is just the point. So if t is 3, then I'm just going to plug that in, right? So x is 3 squared plus 1, so that's 10. Y is 3 cubed, 27, minus 12, so y is 15. So my point is 10, 15. And then my slope, well, that is dy dx. So here, this is dy dt over dx dt. But these are easy, right? So my derivatives with respect to time, I mean, these are just polynomials. So my dx dt is going to be 2t, and my dy dt here is going to be 3t squared minus 4. All right, well, then I can just plug that in, right? So I get 3t squared minus 4 over 2t. And so at t equals 3, I can just plug it in. So I get 27 minus 4, 23 over 6. And so my tangent line would then be y minus 15 is equal to 23/6 times x minus 10. All right. What if I wanted to know, where is this horizontal? Where do I have a horizontal tangent line? So this is asking me when dy dx is equal to 0, right? Well, we can set that up, right? So dy dx is 0. And of course, this is still 3t squared minus 4 over 2t. So when is this going to be true? Well, we're just looking for when is 3t squared minus 4 0 and this not 0, right? Because we don't want an indeterminate form here. So we're just solving for t. So this is going to be, right, t squared, 3t squared minus 4 is 0. So t squared is 4/3, and thus t is plus or minus 2 over the square root of 3. And so this tells you when, but not so much where, right? If you wanted to find the where, you would plug these in, plug this t, or the 2t values into x and y to find the points where this happens. So for your exercise here, I want you to consider this parametric equation, right? So x is cosine, y is sine of 2t. And I only want you to consider t values between 0 and 2 pi. And so what I want you to do is find the tangent line equation when t is pi over 4. Okay, so let's do a more real-world example, although not super real-world example, because these functions are definitely completely made up. But we're going to assume we have some particle following a trajectory given by this parametric equation. So we'll let x of t, right, x is a function of time, be 1/4 t cubed plus 2t, and y of t be 20t minus t squared. So the way you want to think of this, right, in terms of the physical world, is that this is your horizontal component, and the y of t is your vertical component, right? So you can kind of break down the motion into the horizontal and vertical components, respectively. And so I want to know, what is the maximum height this particle reaches? Well, we know how to do this stuff from calculus, right? Like if you have some, so you could try to eliminate the parameter, get y in terms of x, find dy dx, is 0, right? Because if we look for a maximum, it should happen at a critical point. And here, our derivative should mostly be nice. So we want to think of dy dx equals 0. Well, what is dy dx? Well, this is dy dt over dx dt. And in this case, dy dt is going to be 20 minus 2t. Dx dt is going to be 3/4 t squared plus 2. Well, when is this equal to 0? So first of all, I don't have to worry about my bottom ever being 0. And so this is the only critical point that I would have, right? And when this is equal to 0 is going to be when t is 10. Well, great. So now I know when I hit the max height. Now I just have to figure out what that height is, but that just requires me plugging into the vertical component, right? Because that is height. And so I just plug in my 10 time into my y function, and I get 200 minus 100. And so my max height is 100. And for your second exercise, I want you to look at this parametric equation and find at what points x, y is the tangent line horizontal. Notice that this is plural. You should be finding 2 points. And that's it. So thank you for watching.